Okay, number 72.
It's really hot here.
Okay, so as k goes from 3 to x, so we don't know what n is. 6k minus 5, and we're told that if we add all that up, we're going to get 928. So I know that I'm going to use the formula S sub n equals n divided by 2 times the first term plus the nth term. So n is the number of terms. I don't know how many terms that is. But remember what we said was you could subtract and add 1. Remember that? Okay, so x minus 3 plus 1, which is x minus 2. So that's how many terms we have. I don't know what x is. The first term is what we get when we put a 3 in here. So that's 13. The xth term, whatever that is what we get when we put x in there. And I already know that if I add all these together, I'm going to get 928. So I'm going to use my formula. So the sum of those n terms is 928. I don't know n, but I know it's x minus 2 divided by 2. The first term is 13. The x term is 6x minus 5. So 928 times 2, I'm going to go ahead and do that, put that up there, is x minus 2 times 8 plus 6x. So that's going to be 1,856, am I right? Yep. And this is the FOIL method. So 8x plus 6x squared minus 16 minus 12x. That's a quadratic equation. I'm going to get everything on the same side. So 6x squared. 8x minus 12x is negative 4x. Minus 16 minus 1,856. And that's going to be, oops. $1,872. And then from there, I could just use the quadratic formula. Okay, so you're going to get two answers. If one of them is negative, you know it's not going to work because this is a term number. You can't have a negative term number. It's pretty complicated. Any other questions?
I got my notes, Miss Cindy, because I didn't know if you put it in the computer.
I got it. Thank you. Are we good?
Oh, boy. See, what's confusing is...
Yes, you got to do the quadratic formula to find x. Yeah.
See, what's confusing?
Today we're actually going to cover 2 lessons, so that's why I'm not going to take all the time to do the quadratic formula. Other questions about that? Any other problem you'd like to see worked? Okay. Today we're going to talk about geometric sequences and geometric series. Now, we've talked about arithmetic sequences. We said that the definition of a sequence is a list of numbers in a particular order. Okay? When we talked about arithmetic sequences, we said that the way that you got from one term to the next term was to add one or add some constant. In this case, I add 5 each time. So think about that. The first term is a 5, the second term is a 10, the third term is a 15. If I think of those as ordered pairs, 1, 5, 2 is 10, 3 is 15. If I graph those, I'm going to get a line. That's a linear relationship. Now, hopefully they make sense to you because the constant difference is 5. Every time I go from one to the next one, I just go up 5 every time. That's the definition of slope, right? So, that is a linear relationship. Now, that differs from a geometric sequence. A geometric sequence is a sequence in which each term after the first term is found by multiplying the previous term by a constant R called the constant ratio. Okay? So R is the constant ratio. So in a geometric sequence, the way we go from one term to the next term is we multiply by some number. Instead of adding, we're going to be multiplying. And I'm going to send this. This is a PowerPoint, and I'll send you an email with the PowerPoint on it. So now, when we graphed an arithmetic sequence, we got a line. What do you think is going to happen